All right, so today we're diving deep into the world of data science and machine learning.
Sounds exciting.
It is. But for folks just getting started, it can seem a bit intimidating.
I can see that.
We're going to break it all down, though, like step by step.
Yeah.
How a data science project actually works from start to finish.
A lot of people think data science is just about like number crunching and making those fancy charts, but
Yeah, there's way more to it than
well,
that.
there is, yeah.
So maybe, like right off the bat, what actually is a data science project?
Okay, so a real data science project, it uses data and models to solve very specific problems that businesses have.
So not just like summarizing like what happened in the past.
Right.
It's like using the data to,
Predict the future.
predict the future, yeah, and make decisions.
Exactly, make better decisions, yeah.
Okay, cool. So you mentioned data and models. Can you break those down a little bit more?
Sure. So data, first of all, that's like the key ingredient, right? It's what we use to train our models, like teaching a computer to see patterns.
Mhm.
And then the models themselves, those are like the brains of the whole operation.
Like,
They're basically like sets of instructions, right? That learn from all that data and then use that to make predictions or help make decisions.
so like teaching a dog new tricks, but instead of the dog, we've got a computer
Exactly. Yeah.
that's learning all these cool things from the data. I bet there's different types of data, though, right?
Oh, yeah, for sure.
That we can use.
Absolutely. One of the big distinctions is between offline and online data.
Okay.
So offline data is historical stuff. Think of like, a company's sales record
Okay.
or climate data from way back. That's, static data.
Gotcha.
It's usually stored somewhere,
Yeah.
a database. Online data, that's totally different. That's always coming in like, real-time streaming data.
No.
You could think of sensor data from a self-driving car.
Oh, interesting.
Or, like livestock prices, constantly changing.
So how do those like different flavors of data, how does that impact the kinds of data science projects that we can actually create?
Well, it really changes the game, right? Because based on the data you have and how you're going to use the model, you end up with like 3 main categories of data science projects.
Ooh, 3 categories. Tell me more about those.
All right, so first you've got what we call offline training, offline application.
Okay.
Those are kind of like one-time investigations.
Okay.
So you're analyzing historical data to maybe understand like why customers are leaving the company. You train the model using offline data and then apply it to a different set of offline data.
Gotcha. So you're like a detective working on a cold case, looking at clues from the past.
Yeah, that's a great way to put it.
So what's the next one? What about the second category?
All right, next up we have offline training, online application. This is where things get really cool.
Ooh, okay.
So you train your model on tons and tons of offline data. Think of Netflix using your watching history to recommend movies.
Uh-huh.
Right?
Yeah.
But then you take that trained model and let it make real-time decisions with the new data that's always coming in.
So it's like you train this chess-playing AI on millions of games.
Yeah, exactly.
And then you have it play against like real human opponents, like live.
That's it. Yeah.
That's pretty cool.
Yeah.
Okay, so what about the last one?
All right, so the last one is it's the most dynamic type. It's called online training, online application.
Okay.
And these models, they're constantly learning and adapting as new data comes in. Think about a self-driving car's AI.
Wow.
It's always adjusting how it's driving based on what's happening around it, like the traffic, the road conditions, if people are walking nearby.
Yeah, that makes sense. So it seems like each of these project types, comes with its own like set of challenges and
Right.
rewards. I think for this deep dive, let's focus on offline training, online application projects.
Okay, good choice.
The ones where, we train a model on a bunch of data and then we set it free.
Yeah, those are like really common
Yeah.
and have a huge impact on a lot of different industries. Think about recommendation systems,
Okay.
like, what Amazon uses or Spotify.
Yeah, I use those all the time.
Right, exactly.
Okay, cool. So walk me through like a typical life cycle for that kind of project.
All right, so imagine we're building a system to try and predict, which customers are going to leave
Oh, okay.
for like a phone company.
Like a cell phone company.
Yeah, exactly. They're
Okay.
losing customers and they want to figure out how to like keep people happy so they don't leave.
Right. That makes sense.
So the first stage of our project is all about figuring out what the problem is
Okay, so really defining that.
and then planning how to actually tackle it.
Yeah, so kind of back to basics. Like, what are we actually trying to do here?
Exactly. And how will we know if we're succeeding, right?
Yeah. How do we measure success?
Yeah, it's like drawing a blueprint before you build a house. So in this stage, we work really closely with the company, the phone company in this case,
Uh-huh.
to understand what they're really trying to achieve,
Yeah.
what data they have available. Like, do they have customer demographics, billing history?
Right.
And what does success actually look like for them? Do they want to like reduce how many people leave by a certain percentage?
Gotcha.
Things like that. And of course, we have to consider, you know, budget, how much time we have, the resources we have to work with.
So it's not just about building this cool model.
Right.
It's about, like, solving an actual problem
Exactly.
in the real world.
Exactly.
Okay, so once we have a good plan in place, then what? What comes next?
So then we get to the heart of the project, the modeling stage. This is where the magic happens.
Okay, so this is where we get to really dig into the data.
Yeah. Yep, exactly. But before we can like unleash the algorithms, we need to prepare all that data. And there are a few key steps there.
Okay.
First up is data cleaning. It's kind of like prepping your ingredients before you start cooking.
Okay.
We got to find and fix any errors in the data, any inconsistencies,
Yeah.
missing values. We want to make sure we're feeding the model good stuff, you know?
Right, so no rotten tomatoes in our data salad.
Exactly, exactly. High quality data only.
Gotcha.
Then comes pre-processing. This is where we transform the data into a format that our models can understand. You might need to change words into numbers
Okay.
or scale the values differently, maybe create new features from the ones you already have.
So you're basically, like, massaging the data into a shape that the model can easily digest.
Yeah, that's a great way to think about it.
Okay, so we've cleaned the data, we've prepped it. Now what?
Now comes the really fun part. We get to choose which model to use. This is where we can explore different algorithms and figure out which one's going to be the best fit for the problem we're trying to solve and the data we have.
Right.
Like, do we want to go with a simple linear regression or something more complex, like a neural network?
So many choices.
Yeah.
How do we know which one's the right fit?
Well, it depends on a few things. You know, what kind of data we have, how complex the problem is, and how accurate we need the model to be.
Okay.
We often experiment a bit with different models,
Yeah.
try them out, and see how well they do on a small part of the data first.
So we don't want to use, like, a butter knife to cut a steak.
Exactly.
We need the right tool for the job.
The right tool for the job, yeah.
But how do we know if the model we've chosen is actually doing a good job? Like, how do we test it?
Right. That's super important.
Yeah.
That's where model evaluation comes in. So once we've trained the model, we need to see how well it does on data that it's never seen before. This helps us make sure it can handle new information, new data, and that it's not just memorizing the data it was trained on. We call that overfitting.
Oh, overfitting. Sounds bad. What's that?
Yeah, it's something we want to avoid. So imagine you're training a model to recognize cats, right?
Okay.
But you only show it pictures of fluffy white cats.
Mm-hmm.
It might get really good at recognizing those specific cats, but then if you show it a black cat or a hairless cat,
Yeah.
it might totally fail.
Oh. So we want our model to be a cat expert, not just a fluffy white cat expert.
Exactly.
Yeah.
Exactly. We want it to be able to like generalize,
Right.
handle different types of cats.
Okay. So how do we prevent that overfitting problem?
Well, there are some techniques we use, like cross-validation. We split our data into like different chunks, and we train our model on different combinations of those chunks.
So it's like giving the model a bunch of pop quizzes to make sure it's really learning,
That's a good way to think about it, yeah.
not just memorizing the answers.
You want it to be able to handle new questions, new situations.
Okay, this is all super interesting. So what happens when we have a model that's, like, performing well and it's ready for, prime time?
All right, well, then we move on to the next exciting stage,
Okay.
which is all about implementing our model and getting it ready for the real world.
Okay, so now we're taking our model out of the lab and setting it free in the wild.
Exactly. So we're back and we're talking about how to take our model, the one we've been training, and get it ready for the real world.
Right, like, it's finally time for our AI to, spread its wings and fly.
Yeah.
But it can't be as simple as just, like, flipping a switch, right?
You're right. It's definitely not that easy. There's a lot to think about when you're putting a data science model into a real live environment. It's not just the model itself. It's about building a whole system to support it.
Okay, so let's break down what we need to do to implement this model. What are the, main steps?
One of the first things we need to figure out is how the model's going to get new data in real time. Remember, we're talking about those offline training online application projects. So we trained it on like static data, but now it needs to work with information that's constantly changing.
Right, yeah. So it's like we're connecting our model to like a fire hose of real-time information.
Exactly. And to handle all that data, we need to build a data pipeline. It's a system that collects, processes, and feeds the right data to the model. And it has to do it quickly and efficiently.
Okay, so it's kind of like building a like a really fancy plumbing system to make sure our model's always getting the freshest data.
Yeah, that's a great analogy. A good data pipeline is super important if we want our model to work well out in the real world. But
Okay.
it's not just about the data flow. We also have to think about where our model is going to live, where it's going to run.
So we need to find a good home, like a place where it can thrive and do its thing. What are our options there?
We have a few choices, and it really depends on the project. We could use a cloud platform like AWS or Azure, or maybe the company has its own servers we could use. And for some projects, we might even put the model on edge devices. Those are good for stuff that needs super fast responses, like self-driving cars.
Edge devices. What are those?
So edge devices are basically things that are located really close to where the data is coming from, like smartphones, sensors, even smart refrigerators.
Oh, oh,
If we put the model directly on those devices, it can process the data and make decisions much faster.
makes sense. Okay, so we've built our data pipeline and we've picked a place for our model to live. Are we ready to set it loose?
Almost. Before we do that, we want to test it really well in a controlled environment. And for that, we use something called shadow mode.
Shadow mode. Sounds kind of mysterious.
Yeah.
Like our model is working undercover.
Kinda, yeah. So in shadow mode, our model is running alongside the real system, processing real data and making predictions, but it's not actually affecting anything yet. It's like a test run.
Oh, so it's like our model is doing a practice performance, but nobody's watching yet.
Exactly. It gives us a chance to see how our model behaves with real-time data, look for any problems, any weird stuff that might happen before it has a chance to cause real trouble.
That's really smart, like a safety net. So what kind of things are we looking for during this shadow mode testing?
We want to see if our model's predictions match up with what actually happens. We're checking to make sure it's still doing a good job with new data and that it's performing the way we expect it to. We're also looking for like any unexpected behaviors, like maybe the model is making predictions that are way off or showing biases that we didn't see before.
So it's like a final dress rehearsal where we make sure everything's running smoothly before opening night.
Exactly. Shadow mode gives us the confidence that our model is ready for the spotlight and can handle the real world.
Okay, so let's say our model has passed all its tests in shadow mode. We're feeling good about it. What happens next?
Then it's time for the big test, A/B testing.
Oh, A/B testing. I've heard of that for like websites and marketing stuff. How does it work for data science?
It's the same idea. We want to compare our new model to the old way of doing things, but we do it in a real-world setting. So we split our audience into two groups. One group keeps using the old system, that's the control group, and the other group gets to use our new model. We call that the treatment group.
So it's like we're running a science experiment, comparing the results of two different approaches.
Exactly. And to make sure it's fair, we randomly assign people to each group. That way, we know that any differences we see are because of the model and not something else.
Makes sense. What are we measuring during the A/B test? Like, what are we looking for?
It depends what we're trying to achieve with the project. So for our phone company example, maybe we're tracking how many customers leave, how much money they spend, and how satisfied they are. We compare those metrics between the two groups to see if our model is actually making things better.
So we're basically running two parallel universes, one with our fancy new model and one without, and seeing if the model makes a difference.
That's a great way to put it. And the best part is, A/B testing gives us real numbers. We can see not just if the model is working, but how much of an improvement it's making.
This is really cool. It's like data-driven proof that our model is worth it. But I bet A/B testing can be tricky to set up right.
It can be, especially if you're working with a lot of people. We have to be careful about how many people are in each group, how long we run the test, and make sure our results are statistically significant.
Okay, so we've run our A/B tests, and the results are in. Let's say our model is a huge success. It's predicting who's going to leave the phone company, and it's helping them keep customers happy. Are we done now? Can we celebrate?
We're definitely getting close. But our work isn't over just yet. Even after we launch our model, we have to keep an eye on it. This is the post-production phase.
So it's like launching a rocket. Getting it into space is a big deal, but then you still have to track it and make sure it stays on course.
Exactly. The real world is always changing. Customer behavior changes, new data becomes available, even the company's goals might shift over time. And our model needs to be able to adapt to all of that.
Okay, so how do we keep our model fresh and up to date?
We have to keep track of how it's performing, looking for any signs that it's not working as well as it used to. We call that model drift. And we might need to retrain the model with new data or even tweak its settings a bit to keep it performing at its best.
So data science is a never-ending story. It's not like you build a model and then walk away. You have to keep working on it, nurturing it, making sure it's still relevant.
Exactly. It's all about continuous learning and improvement.
This has been fascinating.
Mm.
I'm really starting to see how much goes into taking a model from an idea to something that's actually making a difference in the world. But we haven't talked about one important piece yet, have we?
You're right. We've talked about building, testing, and deploying our model, but we haven't covered how we actually share our results with the people who need them.
Right, how do we communicate all of this to the stakeholders, the people who are going to be using our model and making decisions based on it? That seems pretty crucial.
It is crucial. What good is a brilliant model if no one understands it or knows how to use it? We need to be able to explain our findings in a way that makes sense to everyone, even if they're not data scientists. And that brings us to our final stage, communication.
All right, so we're back for the final part of our data science deep dive. We've gone through the whole project lifecycle. We built the model, we tested it, we even launched it into the real world. But now it's time to show off what we've accomplished.
Right. We got to tell the story of our data, translate all the insights we found into something that everyone can understand.
So we're putting on our storyteller hats, ready to share the data wisdom we've uncovered. But who are we telling this story to? Who's our audience here?
Well, it depends on the project, really. It could be business leaders who are making big decisions, product managers trying to improve things for users, even like the employees who are directly affected by what our model does.
Right, so we have to change how we talk about it depending on who we're talking to.
Exactly. We got to speak their language. Like a CEO might want to know how the model is impacting the bottom line. Is it boosting revenue, saving money, making customers happier?
Makes sense. But a product manager might want to dive deeper into the specifics of the predictions and how they can use those to make their product better.
Yeah, it's all about finding that balance, giving them enough context without overwhelming them.
So how do we actually do that? How do we communicate these findings effectively? We're not just sending them a spreadsheet full of numbers, are we?
Definitely not. Numbers are important, but just showing raw data isn't going to cut it. We have to turn those numbers into something that people can actually grasp.
Okay, so what do we do? Tell a story with the data.
Yeah, exactly. Data visualization is super helpful. Charts and graphs can show complex stuff in a way that's way easier to understand.
A picture's worth 1,000 words, right? Especially when it comes to data.
Right. But visuals alone aren't always enough. We need a narrative, a story that highlights the problem we're tackling, the data we used, the insights we found, and how our model is making a difference.
So it's kind of like a detective novel, where we're leading the reader through the clues and the investigation. But instead of a whodunit, it's like a data mystery.
Exactly. And just like a good mystery, our data story needs a clear beginning, middle, and end. We got to capture the audience's attention, keep them engaged, and then deliver a satisfying conclusion.
This is awesome. I'm seeing how data science isn't just about the technical stuff. It's also about storytelling and communication. But I imagine that communicating these findings can be pretty tough. What are some things we should avoid?
Well, for starters, we can't use too much jargon. Not everyone's a data scientist, right? We
No.
got to use plain language that everyone can understand. And we can't get so lost in the technical details that we forget to talk about what really matters. Our audience cares about the impact, not the algorithms themselves.
So finding that balance again, giving them the right amount of detail, but always connecting it back to the bigger picture.
Exactly. Another important thing is being transparent. We got to be upfront about how we got our results, any assumptions we made, any limitations of the model.
Transparency is key. It builds trust.
Right. Our audience needs to trust our findings if they're going to make decisions based on them. And speaking of making things engaging, there are some cool tools we can use. Like interactive dashboards are awesome because they let people explore the data themselves.
Oh, cool.
Yeah, they can uncover their own insights. And, you can use animation, motion graphics, even a good old-fashioned presentation. It's all about bringing the data to life.
So we're like data artists, painting a picture with our findings.
I like that. Data science is definitely a blend of art and science, and communication is what connects the two.
This has been an amazing journey exploring the world of data science. We've seen how to take a project from a simple idea all the way to a solution that's actually making a difference. And we've learned that data can really change things, drive innovation, and shape the future.
It's been great diving deep with you. And for everyone listening out there, keep exploring, keep learning, and never stop asking questions. The world of data science is always evolving, so stay curious.
Well said. And to all our listeners, thanks for joining us on this deep dive. We hope you've gained a new appreciation for the power of data science. Until next time, keep on exploring and keep on learning.